factoring. Now you should have seen this before, but it's going to be a review, but we've got to make sure that the skills are there. This is a skill, factoring trinomials, that's going to come up between now and Christmas. It's always going to be here. Okay, so it's going to rear up when we do polynomials, and so it's going to be here. So we've got to make sure we're confident when we run into quadratics. Now, quadratic is something that has an x squared term. Okay, so we need to be able to factor quadratics that look like this. What's the difference between these two forms? Yeah, so yeah, this one has a 1 in front of the x, and this has a number that could be any number. Okay, so there's slightly different ways of doing that. So this would look something like, x squared plus, 5x plus 4, and this might be 2x squared plus 3x plus 7. That's what I mean by the difference between the two. This one has a 1 in front of the x squared, and this one has a number other than 1 in front of the x squared. Now, how do you multiply these two things together? You have an acronym that helps you. Maybe I didn't hear it. FOIL, yeah, that's it. So you learned somewhere that this is an acronym for multiplying the first terms, the outside terms, the inside terms, the last terms. When I multiply the first terms, I get x squared. When I multiply the outside terms, what do I get? 3x. When I multiply the inside terms, I get 2x. And when I multiply the last terms, I get 6. So this is x squared plus 5x plus 6. Okay?
How did you get the last 3?
Okay, so when you multiply these two binomials, you multiply the f means multiply the first two terms together. So multiply those together and I get this, okay? And then the O means multiply the outside terms. So outside terms means this one and this one. That gives me the 3x. And then when I multiply the inside terms, that's when I get the 2x. And then when I multiply the last terms, that's where I get the 2 times 3. Okay, so if you need to write FOIL down and then first, some people do it, where they have things like this. They do, some people will write, x plus 2 times x plus 3, and they'll do something like this. The first two terms get multiplied, the outside terms, the inside terms, and then the last terms. So there are 4 different multiplications that need to happen there. Okay, so some people do it like that to keep them all straight. And then I made a mistake on this. This last one is there. Okay, so the first two terms get multiplied, the outside terms, the inside terms, and then the last terms. Okay, so however you keep track of that. Yes. This would have been probably started in middle school and Algebra 1. So we're just trying to bring this one back, okay? So what happens is that when you multiply, everything here gets multiplied by everything there. Everything, so this has to get multiplied by x and 3. This has to get multiplied by x and 3, okay? So the answer is not x squared plus 6. You don't just pick x squared plus 6 and you're done, okay? So it's 4 different things have to come out of that multiplication. Now, so this is what we called using the FOIL method. What we're basically going to do when we factor is we need to get from here, we need to start with this, and we need to end up with this. So we need to start with something that looks like this and factor it back to something like this. This is what we're going to use for solving equations. Now again, when you multiply things together, remember this has to be FOILed. You cannot just say this is x squared plus y squared. That is not wrong. I mean, that is wrong. So this doesn't work. So you have to FOIL that. You have to multiply the first terms, the outside, the inside, and the last. Now, what we need to do is talk about how we start with something that looks like x squared plus 5x plus 6. How do we get that factored into x plus 2, x plus 3? Okay, so I've got a bit of a visual here. I didn't show this last year. I'm just going to see if this helps you think about it. So I've got x squared plus 5x plus 6. Here's x squared. How many x's do you see? 5x. And then how many of these are there? 6. So do you agree this is x squared plus 5x plus 6? Does that look right? So this is x squared plus 5x plus 6. X squared, 5x's plus 6. Okay? So this box, if I look at the area, this box is x by x. That's how I get x squared. Okay? This box is x by 1, 1, and 1. And so this side is x. Okay? And this side right here, this is 1. That's 1. This side is x. Okay? So what is this? This is x plus what? 3. And this is x plus 2. So the area of this whole thing is going to be x plus 3 times x plus 2. Pardon me? Okay. So if you look at it, this box is, the dimensions of this box are x by 1. This is x by 1. This is x by 1. It's a rectangle. This is x. This is 1. This is x. This is 1. This is x. This is 1. Okay. This box is x by x. It's a square. This box is x by 1, x by 1. And then if I fill in all of these with 1, this is 1 by 1, 1 by 1, 1 by 1. Okay? So this is x squared plus 5x plus 6. But another way of looking at it, the distance from here to here, this is x plus how many? 3. The distance from here to here is x plus how many? 2. So the area of this whole thing is x plus 3 times x plus 2. Okay, so this is how we will factor it. Now, this is just a visual. If this doesn't help you, we're going to move on to more concrete steps of how to factor. This is just showing you visually what happens, that this can be factored, and we'll talk about how this happens. Okay? So we're going to have very concrete steps for how we do this. If I need to factor, x squared plus 5x plus 6. This is the way you're going to see me do this every time we do this in class. In order for this to factor, I need to find two numbers. Those numbers need to do two things for me. Those numbers need to multiply to give me a 6, and they need to add to give me a 5. Now, where did I get that from? Where did I get those numbers? Yeah, I mean, they multiply to give me this last number, and they're going to add to give me this inside number. Okay? What two numbers will multiply to 6 and add to 5? Yeah, 3 and 2. Okay, those are the numbers that are going to make this happen. Now, if you can't just think 3 and 2, what are the factors of 6? It's 1 and 6, 2 and 3, and then what? 3 and 2, 6 and 1. That's it. Okay. Which of those numbers can you add and get a 5? 2 and 3. Okay, that's my answer. So once I know that the 2 and the 3 are the numbers that make this happen, you go straight to your factorization. X plus 2, x plus 3. So if that box that I drew a minute ago confused you, these are the steps. Okay. When you see something that looks like x squared plus bx plus c, you're going to need to find two numbers that multiply to give you c and add to give you b. Once you find those numbers, you go straight to your answer. Okay? Yes. Okay, so let's do another couple practice here. I think you've seen this before. Is it starting to come back, or? Okay. Yes. Oh, the one we just did? Okay. So the key here, I always write this step down. I mean, I'm not going to grade this over here, but this is just something that helps. I need two numbers that multiply to 6 and add to 5. Let's figure those numbers out, and that gives me my answer. X plus 2, x plus 3. What if this had been 2 and negative 3? What would my answer be? If this had been 2 and negative 3, what would my answer be? X plus 2, x minus 3. Okay? So we'll find examples that do that. So here, x squared plus 13x plus 42. In order to solve this, I'm looking for two numbers. What must those numbers multiply to? 42. And what must they add to? Add to 13. Okay? So does anybody know what those are? Pardon me? Yes, 6 and 7. Now, if you didn't know that, you can come over here and you can say 42. That's 1 times 42. That's 2 times 21. That's 3 times, what is it, 14. And 5 and 6 times 7. And then it starts to repeat, 7 times 6. So which of those numbers add to give you 13? Yes, 6 and 7. So 6 and 7 are the two numbers here. So what's the answer here? Yeah, x plus 6, x plus 7. That's it. This is factored, okay? How could you check and make sure that's right? You could multiply this back out. When you multiply this back out, you would get x squared, that's the first terms, the outside terms, plus 7x plus 6x plus 42. So that's x squared plus 13x plus 42. So you're not required to do this, but this is how you could check and make sure that answer is right. And see what happens is you see these numbers multiply to give you that number, and then these numbers have to add to give you the number of x's. Okay. Let's look at another example. So in this one, I need two numbers that multiply to give you what? Negative 24. So we've got a negative in here, and they add to give me 5. So if these numbers don't just jump out at you, and they will after a while, but what are the factors of 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then I get to 6 and 4, then they start repeating. Is there any way these numbers can be combined so that you get a 5? Yeah, so the negative 3 and the 8 would give you a positive 5, right? Yeah, so this tells me a negative 3 and an 8. When you multiply those numbers, what do you get? Negative 24. When you add those numbers, what do you get? 5. That means these numbers represent my answer. So what's the factorization here? Yeah, x plus 8, x minus, it doesn't matter which order. X plus 8, x minus 3. That's how that gets factored. Okay? Now, have you seen this before, or maybe you did it a different way, or? Yeah, I tend to always do it this way just to be consistent, and there'll be a little bit of change when we have a number other than 1 in front, and we'll do that. So let's do the next one, then I want you to work on a couple. Here, I need two numbers that multiply to give me what? Negative 18, and add to give me 7. What numbers can do that? Yeah, so negative 2 and positive 9. Those numbers add to negative 18 and they add to 7. So what's the answer here? Yeah, a minus 2, a plus 9. The variable here is a, not x. That's the change there. Probably. Come on, that's an easy thing. The x got replaced with an a. Okay, the next one here. You guys work on these two, okay? I'm going to pause for a second. You're looking for two numbers that multiply to negative 10 and add to 9. The only factors of 10 are 1 and 10 and 2 and 5. Right? How can you combine those so that you get a 9? Yeah, 10 minus 1. So I will always, when I get to here, I'll double check. Can I multiply these numbers and get that number? Yes. Can I add these numbers and get that number? They're correct. So what's the answer? X minus 1, x plus 10. And when we get over here, I need two numbers that multiply to give me what? Negative 36, and add to give me negative 5. Yeah, so 9 and 4. If you do this for a while, you'll get the hang of it. If you didn't know that, you can just come over here. It's 1 and 36 2 and 18, 3 and 12, 4 and 9, 6 and 6. Those are the only ways to get 36. And then, which is the only way I can add those together and get a negative 5? Yeah, the only way I can get a negative 5 is this scenario. So when you multiply those numbers, you get negative 36. When you add them, you get negative 5. So the answer is what? X plus 4, x minus 9. Okay? Now, the other thing, so that takes us to, we've done this in previous lessons, we've done this. We've got one more case to handle. That's when the number in front of the squared term is not 1. So here's the difference on this. When I need to factor something like this, I've got to find two numbers that multiply to give me, and what I need to do, I need to find two numbers that multiply to give me a times c, and this is written in the form. This is ax squared plus bx plus c. So a times c, and then they add to give me whatever b is. So in this case, what is a times c? 2 times negative 24, negative 12 is negative 24. And they have to add to give me a what? 5. Okay. So that's the difference. When you looked at, when there was a 1 in front, you looked for two numbers that multiply to give you c. When the number in front is not a 1, you have to look for two numbers that multiply to give you a times c. So in this case, I need two numbers that multiply to negative 24 and add to give me 5. So I'm looking for two numbers that multiply to negative 24 and add to give me a 5. What numbers will do that? Yeah, an 8 and a negative 3. And then I'll just double check. When I multiply those numbers, I get negative 24. When I add them, I get a 5. Now here's the big difference you got to hang on to. I'm going to rewrite this equation. 2x squared. I'm going to take these numbers you see right here. I'm going to say plus 8x minus 3x minus 12. Okay, what's 8x minus 3x? 5x. So are these the same equations or same expressions? Yeah, so all I did was I rewrote 5x as 8x minus 3x. Okay, so this is 2x squared. Instead of writing 5x, I wrote 8x minus 3x minus 12. How many terms do you see here? 4. What's the only method we have for factoring something with 4 terms? Grouping. So now, by you doing this exercise, this is guaranteed to factor by grouping. So to factor this by grouping, I'm going to look at it like this. What do the first two things have in common? They have a 2x in common, right? So what do you multiply 2x by so that you get 2x squared? X. What do you multiply 2x by so that you get 8x? 4. Okay. Here's a minus sign. Copy that minus sign down. What number do these next two things have in common? 3. What do you multiply a negative 3 by so that you get negative 3x? X. What do you multiply negative 3 by so that you get negative 12? Plus 4. If you've done this correct, you should see the same thing in parentheses. Now, how does this factor? Yeah, this is 2x minus 3 times x plus 4. So this case is a little bit harder, an extra step. You do this similar thing, find two numbers that multiply to give you whatever this number is times this, add to give you the middle number. Once you find those numbers, your answer is, here's the big thing, your answer is not x plus 8, x minus 3. If you take x plus 8, x minus 3, you will not get 2x squared plus 5x minus 12. So when the number in front is not a 1, you have to take these two numbers, rewrite the equation into 4 terms so you can factor by grouping, and then you go to your answer. Now this may be a couple of extra steps. When I was a kid, they taught us, put a 2x and an x and just start guessing for numbers, and I don't really like that. This is a formula that's going to work every time. Now somebody asked the question, I wrote 8x minus 3x. What would happen if you wrote minus 3x plus 8x? If you wrote it in a different order, doesn't matter. Okay, you're going to get to the same answer. So there's no magic for that. Let's take a look at the next one here. Pardon me? Sure. You multiply this and this. Okay? So to factor something that looks like this, you have to, a times c, you have to multiply the first number and the second number. So when this was a 1, the previous problems, you only found numbers that multiply to c and add to b. So if the number in front is not a 1, multiply that, and that's what you're looking for. So let's look at another example. So this one gets a little bit harder. I need to find two numbers that multiply to give me what? 6 times negative 15. What is 6 times negative 15? Negative 90, okay? So two numbers that multiply to negative 90, and they add to give me what? Positive 1. So two numbers that multiply to negative 90 and add to 1. Does anybody know what those are? What are they? So a 10 and 9 multiply to 90, right? 10 minus 9 is 1. Yeah. So these numbers are going to be 10 and negative 9. When you multiply those, you get negative 90, and when you add them, you get 1. Now, this doesn't take me straight to my answer. I have to rewrite this problem so I can solve by grouping. So I'm going to rewrite this as 6x squared plus what? Plus 10x minus 9x minus 15. And then I factor this how? By grouping, okay? So what do those first two terms have in common? It looks like a 2x. So 2x, and what do I multiply 2 by to get a 6? That's 3. What do I multiply x to get x squared? What do I multiply 2x by? Do I get 10x? That's a 5. Copy down the minus sign. 9 and 15, what do they have in common? 3. So I'm going to write a 3. But instead of a 3, technically it's a negative 3. So what do you multiply negative 3 by so that you get negative 9? It's positive 3. And you got the x. What do you multiply negative 3 by to get negative 15? That's positive 5. And if you've done this right, what you see in the parentheses matches. So what's this final answer? Yeah, 2x minus 3, 3x plus 5. Okay. So this is a little bit harder, but you're still doing that similar process, finding two numbers that match your conditions, and then it turns into a grouping problem. Looking at this one, I need two numbers that do what? Two numbers that multiply to what? Negative 18 and add to what? Add to 7. What numbers do that? Yeah, so the only factors of 18, if the numbers don't really jump at you, it's 1 times 18. It's 2 times 9 or 3 times 6. What's the only way you can get a 7 out of those numbers? 9 minus 2, right? So the numbers here are 9 and negative 2. Those numbers multiply to give you negative 18. They add to give you 7. So now what do I do with these numbers? I rewrite this equation as what? 6x squared, and then what? What do I do with these? Plus 9x minus 2x minus 3, and then I go to factor by grouping. So what do these first two have in common? That's 3x, and that leaves me with what? 2x plus 3, okay? And then a minus. Minus what gives me minus 2x? It's 2x, right? And minus what number would give me a minus 3? Yeah.
So you just dropped the 7, like 7x.
Pardon me?
When you rewrite it.
Yeah, so 7 is the same thing as 9 minus 2. By writing it in this way, I'm guaranteed that it factors by grouping, okay? So it eliminates the guessing. So this answer is what? 3x what? Minus 1 times 2x plus 3, okay? So this will pop up again and again. You're going to have times in the semester where all of a sudden you're working a problem, you get a quadratic. You've got to be comfortable in knowing this is our procedure for how we factor these guys. Yeah. So you did the -2 and the +9? Okay, let's try that. So I told you that it would work. So let's just see. I don't want to be made a liar. So let's just do that. So what if you got here and you did, what was it, 6x squared minus 2x plus 9x, and what was it, minus 3? Was it that? Okay. So I need to factor this. If you wrote, instead of writing, so all Olivia is saying is, I wrote 9 and -2. She wrote -2 and 9. This should work to give me the same thing. So what can be factored out of this first two terms? 2x. And that leaves me with what? 3x minus 1. Okay. Plus, and then what can be factored out of here? 3 times 3x minus 1. So this is what? 2x plus 3 times 3x minus 1. So it should match. Okay. Okay. And there are little places that mistakes come in there. Yes, Gilday.
On mini quizzes and little tests and stuff, are you going to say use grouping to factor these and like stuff, or are you just going to give us like options?
On the first quiz, I'm holding your hand a little bit. I'm going to say use the GCF to factor this. Use difference of squares. Okay. Use grouping. And then, but I'm going to say factor this trinomial. You have to know the difference between these two forms, the ones we did. So I'm on this first quiz, I'm telling you that. But for thereafter, it's just going to be factor. And so what you want to try to do, if ever the GCF works, the greatest common factor, do that first. Remember, we saw examples where, when we had things like, 50 minus 32 x squared, okay? The greatest common factor is 2. So when I take that greatest common factor out, then it becomes the difference of squares. Then it became 2 times 5 minus 4x, 5 plus 4x. So you want to be conditioned to do the greatest common factor first. So on this one, I'm holding your hand a little bit on this first quiz. But when you get to the test, you may see something like this that requires both methods, but I'm not telling you what they are. Okay? So that's a good question. Let's look at the next one here. I need two numbers that do what? That multiply to what? 15 and add to 8. What are those numbers? 5 and 3, right? So those numbers are 5 and 3. I use the information to rewrite this problem as what? 5x squared plus 5x plus 3x plus 3. The reason I did that is because now this is guaranteed to factor by what method? Grouping. So what do these first things have in common? Yeah, so that's 5x, x plus 1, plus what are the next two things have in common? 3. 3 times x plus 1. And now I'll go to my final answer, which is what? 5x plus 3 times x plus 1. And I'm good to go. Okay? So you guys take a look at the next two. We can. What did we get on this one? It was 2x. What was your answer? Times x minus 1. Was that it? And then what'd you get on this one? 2x plus 1. So that's 6x plus 7x plus 2. Yeah, okay. So if you had trouble getting to either of those answers, let me know. I'll come around and take a look at it. That takes us to the end of this. So this is the end of our factoring. The reason we do factoring is because factoring is a method we will use over and over again this semester to solve equations. So that's why we've spent a whole week on factoring, because it's a method for solving. So the big distinction today, when you see this, you know, you're looking for two numbers that multiply to give you what? Multiply to give you C and add to give you B. When you get these two numbers, you go straight to your answer. What does that mean? Like if I get the numbers 2 and 3, what do I do with them? X plus 2, x plus 3. Okay, this, you should prefer this one. This one's more straightforward. If I get the numbers -2 and -7, it's x minus 2, x minus 7. So in this one, once you get these two numbers, go straight to your answer. Now, if you did want to do that, you could factor by grouping, add some extra steps, and then you would get to your answer. But it's unnecessary. Now, when you see one that looks like this, the key here is that number in front of the x squared is not 1. You look for two numbers that multiply to give you what? AC, and add to give you B. Once you find those two numbers, you don't go straight to your answer. You rewrite the problem so that it can be factored by, starts with a G. Grouping, okay? So you rewrite it. So you basically rewrite it as B. Once you find these two numbers, when you rewrite that equation, you are guaranteed that it will factor by grouping. It takes the guesswork out. So